strategy we've been using, which is to review a little bit. I looked at the recording of our last session, and we had just started talking about graphing linear equations using intercepts. Let's not forget domain and range yet. Let's go back and let's do a few more domain and range. What's the domain of that?
Oh goodness.
First of all, what's the number one rule? What's the first rule of math?
You can't divide by 0.
Okay, so that tells us that this cannot be equal to 0. Okay?
Okay.
What's the second rule of math? What else can't you do? Can you take the square root of a negative number?
No.
That's the second biggest thing, is that whatever's inside a radical, in other words, I can go down here and say that x minus 1 has to be greater than or equal to 0, and the fact that I can't divide by 0 means it has to be greater than 0, like that. Okay? So this is my domain restriction. Now, tell me what that is in terms of x. In other words, when they want you to talk, when they ask you about domain, they want you to give them an answer in terms of x or interval notation, but x is fine. Solve this inequality. That's all you have to do. What does x have to be?
X has to be greater than 1.
There you go. Notice what that's going to cause. First of all, it's going to cause that to never be 0. Secondly, it's going to cause the inside to always be a positive number. Not even 0. It's going to be a positive number, and that's all you need, is for that denominator to be greater than or not 0, but then because it's a radical sign, it has to be greater than 0. With me?
Yeah.
Sure you ask questions if you don't understand something that I'm saying. Now, that was the easy part. What was the domain of that? What's the range of that?
Anything greater than 1.
Not quite. First of all, let's examine that. Is that positive or negative?
Positive.
Always?
Yeah.
Okay. It's never 0. So we have 1 divided by some positive number. Well, what are the possibilities for that answer?
Oh, anything greater than 0?
Yeah, anything greater than 0. In other words, we have a positive number divided by a positive number, but this bottom could be a fraction. In other words, the bottom might be 1/10. So 1 divided by 1/10 would be 10. In fact, the bottom might be 1/1,000,000th, which would make the whole thing a million. In other words, I can make y pretty much any positive number. Can I make y 0?
Can you?
Yeah. Is there any, by that I mean, can I come up with a value of x that makes y 0?
No.
No, because for y to be 0, the numerator has to be 0. Always. It doesn't matter what the denominator is. If the numerator is not 0, then y isn't 0. In other words, if I have a equals b over c, and I tell you that a equals 0, there's only one possibility. B has to be 0. Doesn't matter what c is.
Okay.
Okay? Okay, so far so good. Now, I'm going to make it just a little more complicated. It's the domain of this function.
Anything greater than 0.
Greater than 1.
Okay, so there's the, so the
In other
domain.
words, what you do is you take whatever's inside the radical sign and you force that to be either greater than or equal to 0. And in this case, it can't even be equal to 0. It's got to be greater than 0. And so when I say x minus 1 is greater than 0, it means x is greater than 1. In
Okay.
other words, the domain did not change. By adding this plus 2, I did not change the domain at all. But I do change the range. Think about what the range was there. The range was y has to be greater than 0. The y could never be a negative number, and it can never be 0, no matter what I make x. Right? So now, what's the range if I take 1 over this plus 2? How does that change it? The range was y greater than 0. Well, what's the range going to be now?
Y is greater than 2.
Yeah, exactly. Has to be greater than 2. There's no way that can ever be a negative number, which means y has to be greater than 2. And there's no way this can ever be 0. So y cannot even be equal to 2. The only way y would be equal to 2 is if this thing I have circled here was equal to 0, and we've seen that that cannot be equal to 0. So y is greater than 2. Now, let's talk about graphing this for just a second. Because you can see all of these things that we're talking about, domain and range, if you can figure out how to graph it. Now, I don't know in this test that they're going to end up giving you to see whether you can go to geometry or not, whether or not they'll let you use a graphing calculator. Do you know? Do you have a graphing calculator?
No, I don't.
Are you going to have to get one? I would think you would have to get one to go to high school in that field.
I think so. I've never used one before, so.
Okay. They'll probably make you get a Inspire.
Okay.
And that's the best one to get anyway. A TI Inspire, they're like $125. You could probably buy one used, but I can't imagine they're going to let you start high school math without a graphing calculator, and the one that pretty much all the schools insist upon now is the TI Inspire. And there's quite a learning curve on that. If you find out for sure that they make you have that calculator, well, let me know and we'll spend a session or two going over it. because I have one and I can certainly help you out. And it's a pretty big learning curve. Are you familiar with the TI-84 by chance?
Probably not.
What calculator? Have you just been using a regular old generic calculator up until now?
Yeah.
Okay, so you haven't used a graphing calculator?
Yeah.
Okay. Well, that's a whole new part of your learning curve for high school math, is getting used to a graphing calculator. And like I said, we can definitely spend a session or two on that. As you get closer and closer to the start of school, you'll find out more as to what they're going to require you to have. And once you find out for sure what they're going to require you to have in terms of a calculator, go ahead and get one, and then let's make sure we have a session or two and I can help you learn it.
Okay.
There's a degree of difficulty to learning how to use these graphing calculators, especially if you're not used to them. So, but anyway, what a graphing calculator would do would be you could put this function into it and it would graph it for you. Now, just to let you know, there's a way to graph this manually without a graphing calculator. First of all, I figure out where my vertical asymptote is. Are you familiar with that word?
No.
All right. Let's not go there then. All right. Let's go back and advance through your other stuff here. Graphing linear equations using intercepts. We did a little bit of this. We graphed linear equations. We just didn't do it using intercepts. Well, let's do this backwards. There is a function, okay? It's a linear function, but it's not in typical format. It's not in y equals mx plus b. Okay, that's the format that we're used to seeing and that allows us to graph it quite easily. With me?
Yeah.
Okay. When they give you a function in that format, I know it's still linear because I can see there's only a y and there's only an x. There's not a y squared, there's not an x squared, so I know it's still linear. And if I wanted, I could just solve this for y, and I could put it into y equals, here, let me write it like this. I could say, and make sure you understand what I'm doing here. See how I get this?
Yeah.
Now, what's the y-intercept? What's the slope?
3.
That's the y-intercept. What's the slope?
Negative 3/4.
Okay, yeah. M is the slope, B is the y-intercept. So, no matter how they give you the function, you can always algebraically solve it and put it into y equals mx plus b format, and then you know what the y-intercept is and what the slope is. So you can always do it that way. But sometimes it's actually easier to graph by figuring out both intercepts. In other words, I don't actually need the slope here. What I need is, first of all, what is the y-intercept going to be?
4.
The y-intercept is x equals what? When I'm on the y-axis, what is x equal to? Important concept.
Negative 3/4 plus.
No. Forget what I just wrote previously. Let's just look at this. If I want to know what is the x value when I'm on the y-intercept, what does it, look at it. What does it have to be? What's the x value where that x is?
3.
There's the x value. There's the x-axis. There's the y-axis. What's the x value? Let me change it so that it's not an x, that it's just a dot. What's the x value at that dot? What's the x coordinate?
I don't know.
0. You see why? In other words, the x values go this way and that way. So if I'm right there, my x value might be 1. If I'm right there, my x value might be 2. But if I am on the y-axis, my x value is 0, always. And that's an important thing to know. Perhaps the most important thing in understanding the xy coordinate plane is this concept. In other words, let's back up a second here. This bothers me a little bit. Can that be the x and y value of that point?
No.
Actually, it could. I have not labeled my grid. So yeah, that could be 1 there, and that could be 1 there. So do you see why the x and y value are 1, 1?
Yeah.
Okay. Now, I'm going to eliminate the grid again, because sometimes it's better to look at these things without a grid. Could that be a point in that first quadrant?
No.
No? Correct. Could that be a point in the first quadrant?
Yes.
No. This first quadrant means the x value has to be positive and the y value has to be positive. Do you see why?
Yes.
Okay. So I could have lots of values there. It's just none of them can be negative. In other words, when I'm in, and when I say the first quadrant, that's the first quadrant, that's the second quadrant, that's the third quadrant, that's the fourth quadrant. So if I'm anywhere in this first quadrant, let's say I pick a point there, well, that might be something like 4, 1. You see why? It's over 4 units on the x-axis, and it's up 1 unit on the y-axis. Now, let's go back again and look at this function. When I am on the y-axis, it does not matter where I am at, the x value is 0. You see that? If I'm there, the x value is 0. If I'm there, the x value is 0. If I'm down there, the x value is 0.
Yep, I got it.
Okay? So, the key thing to know is that when I'm on the y-axis, my x value is always 0. Well, what happens when I'm on the x-axis? What's the y value? When I'm on the x-axis, like there, or there, or there, or there, or there, what's the y value?
0.
Huge concept. When you are on one of the axes, the other value is 0. Okay? So, if I want to graph this function, I can figure out the y-intercept really easily by just setting x equal to 0. So when I set x equal to 0, what is my y value?
0.
Make that 0, solve the equation. What's y equal to when x is equal to 0?
4.
Solve that. 4y equals 12. What's y equal to?
3.
Okay. That's the y-intercept. In other words, this point, 0, 3, satisfies that equation. And you always have to think of these things in those terms. In other words, if I have a straight line, every point on that straight line has to satisfy that equation. Now, where's the x-intercept? Where's it going to cross the x-axis? What's y equal to when it crosses the x-axis?
4. So like 0, 4.
Hold on. What's y? Think about what I'm saying. What is y equal to when I am on the x-axis? No matter where I'm on the x-axis, y is the same. What is y?
0.
Okay. That value is 0. Now, plug in 0 for y and solve for x. What do you get?
4.
Okay. So, I now have 2 points. That makes a straight line. I can connect them with a straight line and continue it. And notice that I was able to graph this thing without figuring out slope. I didn't have to deal with that negative 3/4 slope that we got when we solved this equation and put it into y equal mx plus b. So every now and then you'll run across a linear equation where it's really quite easy to graph because you can graph the y-intercept and the x-intercept. It's really easy to get the y-intercept by setting x equal to 0. It's really easy to get the x-intercept by setting y equal to 0. Now, I don't know the slope of that. I didn't figure it out, but I don't care. If the problem was merely graph it, then I've done so. Now, this says graphing linear equations using intercepts. Well, I didn't quite do that. What I did was I took the linear equation and I figured out what the intercepts were, then I graphed it. But they want to graph it using intercepts. So let me give you some intercepts. 1 point on the line is going to be 0, 6. That's going to be the y-intercept. We'll call it that. And you can tell that it's the y-intercept because x is 0. You with me?
Yeah.
And I'm going to say the x-intercept is 4, which means the y value is what?
0.
So, I've given you 2 intercepts. Well, I can graph this pretty easy. I know that that point is 0, 6, And I know this point is 4, 0. And that's all they said was graph it. Bingo. Done. So if you know the x-intercept and the y-intercept, connect the two with a straight line and you've got the graph of it. It's that simple. You don't even need to know slope. I almost hate to leave that there because there are a few things more important in algebra than slope. And not just in algebra, but in algebra 2, and geometry, and trigonometry, and calculus. Slope is the most important word in math. Okay? So I don't really like talking about straight lines without talking about slope. Tell me what that slope is looking at it that I just drew. What's the slope? I don't need to figure out the equation or anything. What's the definition of slope? What are the two words? Rise over run. If you remember anything at all, remember rise over run. That's slope. You can always go from there. As long as you never forget that, you can always go further. So if slope is rise over run, what's the rise here?
6.
What's the run?
4.
So the slope is 3 halves. But something's wrong. That's not a positive slope. So what should the sign on my slope be?
Negative.
Yeah, it's negative 3 halves. Now, how do I get negative 3 halves? Well, if I start from that point, I actually go down 6. That's minus 6. And then I go to the right 4, which is a positive 4. Well, that gives me negative 3 halves. But you don't really need to concern yourself with the sign, because all you need to be able to do is know what's positive slopes and what are negative slopes. And I think you are good at that. Didn't I test you already on that?
Yeah.
What kind of slope is that? Just positive?
Positive.
What kind of slope is that?
Negative.
No. Notice that goes from lower left to upper right. If I were to put a ball right there, it would not roll uphill. That makes it a positive slope. Just like if I were to put a ball there, it would not roll uphill. That makes that a positive slope. Now, if I put that line on there, what's that slope?
Negative.
Correct. Because if I put a ball right there, it's going to roll downhill. That makes it a negative slope. There's various ways to remember whether slopes are positive or negative. I'm not sure what's going to work best for you. The best way I have of testing people is to just draw a bunch, and usually they figure it out. Okay? Let me do one more. Positive or negative?
Negative.
Correct, because the ball would roll downhill. Positive or negative?
Positive.
Where's the ball going to roll? You're always putting the ball there. You're never putting it on the other side of that line. The ball, in other words, it goes from upper right to lower right. That's a negative slope. It's not a positive slope. It's a negative slope. All right. We'll go back over that again next time, because there's one thing you really need to know, and that's which lines have positive slopes, which lines have negative slopes. So we'll keep on this until you get it 100% of the time.
Okay.
Okay? So I will talk to you Wednesday, I believe. Let's see. Yeah, we're at 3 o'clock Wednesday and Friday.
I have a question.
Okay.
So, do I get how do I look over the, like, past sessions again?
Okay. Let me put it in the chat box. Hold on a minute. I got to figure out where I've got it. Got it right here. This link right here. Okay, I'm going to copy and paste it in the chat box. You see it?
Yeah.
Click on it.
Okay.
And I will do the same. And you're now looking at my YouTube Digital Math Tutor. You see where it says PH?
Yeah.
That's Phoebe Heupel? That's your last name, or Hines?
It's Hein.
Hein, okay. So that's Phoebe Hein from June 22nd, 2017. That's Phoebe's from June 26th, 2017. So this would be the last session we had. If you click on that, it will play the recording of that. So as long as you always go to this site, all you got to do is look for your session. You can see on here the last 3 things on my channel are all your sessions, because don't have a lot of students in the summer, so you're what I've got. And today's session will say PH070317. And
Okay.
it'll take a few hours at least for me to get it uploaded to there. Okay? But it's always this site. In other words, save that. Once you opened it, save it as a favorite so you can always get back to it. And then just look up the proper date for the one you want to watch.
Okay.
Okay? All right. You good to go?
Yep.
I will talk to you on Wednesday at 3.
All right.
All right.
See you then.
Bye-bye.